Alright guys, the last section in chapter 9 is probably the easiest section out of all of them. We're going to find the area of an oblique triangle, so it's going to be a little bit different than what you learned in geometry, because you're going to have a way that you can use like a trig function using sines or using Heron's formula, which is on the next page. There are 17 homework questions, and so for using using the sine function to find the area of a triangle, and I usually say that's find the area using law of sines, then this would be for homework numbers 1 through 6, I believe, for the most part. And then you would use the next formula for 7 through 9. So we're going to take a look at the first one. This particular example is a little bit more challenging, and here's why. To use one of these formulas that's in the box, you need two sides and an angle opposite one of those sides, and we don't have that. So in this particular case, which is why you have a challenging example here, you first need to find side C. And I say that kind of loosely only because obviously it's easier to find angle A first, and we're going to use angle A anyway. So first thing I'm going to do is I'm going to find angle A. Remember that that's going to be 180 minus angle B, which is 21, and minus angle C, which is 131 degrees. So that's going to be that the measure of angle A is 28 degrees. Once we have the measure of angle A, and then we get the measure of angle C, so I guess I'll say technically this should be second, okay? We're going to need side C. Then we're going to do, to find side C, we're going to say B over, we're going to use law of sines, over sine of B is equal to C over sine of angle C. So we're going to plug in, and we're going to get 4 over sine 21 degrees is equal to C over sine of 131 degrees. Don't forget you're solving for C, so I'm going to multiply both sides by sine of 131 degrees times sine of 131 degrees. I like to put that in the back for when it's easier to type in. So when I type it into my calculator, I'm typing in 4 sine of 131 degrees. Don't forget that the parentheses are going to pop open automatically. Please make sure you close that. I know I say that way too much, but you kind of need to hear it over and over again. Divided by sine of 21 degrees, and that's going to tell you the length of side C. So side C is approximately 8.4, and I'm not going to round that, so we're going to say this is our answer that I'm going to use in the formula to find the area. So the area formula that I'm going to use is 1/2 BC sine of A. The reason why I'm choosing that particular formula to use is because that one is actually the one that has the least amount of rounded answers to it in a sense. So we're going to say 1/2 times 4 times, and I'm going to put answer here, and then times sine of 28 degrees. Now I probably am not going to put the time sign in between answer and sine of 28. You could if you wish, and I typically would type in the 1/2 as 0.5. So I would probably type in 0.5 times 4 times answer, and then sine 28 degrees, but this looks weird on your calculator when you press answer and then you type in sine of 28 degrees. So the area is approximately 7.9 units squared. Again, like if you catch mistakes, then you got to let me know that I've made a mistake. So we're going to move on to the next type of problem. On page 2, you have Heron's formula. Heron's formula is a way to find the area when you only have 3 sides given and no angles at all. It's definitely the easiest way to find the area when you have 3 sides given. Okay, and you're not asked to find any angles. S just represents like the semi-perimeter. It's like half of the perimeter of the triangle. So S is for semi-perimeter, and this formula is the square root of S times S minus A times S minus B times S minus C. So you definitely, obviously, when you're doing homework and quizzes, you have everything in front of you. So when I set this up, I'm going to say area is equal to the square root of s times s minus a times s minus b times s minus c. You might want to go ahead and find the semi-perimeter first. Semi-perimeter is a plus b plus c all over 2, which in this case is going to be 9 plus 11 plus 7 all over 2. So the semi-perimeter is 13.5. That is an exact value. When I go to type this into my formula, or when I write it down, I'm going to go ahead and like subtract it in my head because I'm going to be able to do that okay. If you want to subtract s minus a each time, fine. But I'm going to write 13.5. S is 13.5. 13 and then times, and then 13.5 minus 9 should be 4.5, and then times, and 13.5 minus 11 is 2.5, and then times, and 13.5 minus 7 should be 6.5. So I'm going to press the square root key on my calculator first, and then I'm going to type all of that in, and the area is approximately 31.4 inches squared. And that's what I got for the area of that triangle using Heron's formula. In the last problem, and then I don't know if I said, so for Heron's formula, this would be like homework numbers 7 through 9. And then the word problems, kind of like this one at the bottom, this would be like homework number 10 through 12. And then 13 and a couple of the others, essentially the reading assessment questions, the reading assessment or the mixed review, those would be like numbers 13 through 17. They're pretty short. Some of them are just identifying the formula. So if you have the formula in front of you, it's really not going to be that big a deal. Okay, so now we're going to find, we want to determine the total cost to pave the parking lot if the price is $1.15 per square foot, which means essentially we're going to find the total area of the parking lot. And after we find the total area, then we're going to multiply that by 1.15. So it's not too big a deal. Again, since we know what the three sides of the parking lot are, we're just going to use Heron's formula. So remember, we're going to do area equals the square root of s times s minus a times s minus b times s minus c. Okay, so I'm going to go ahead and calculate what the semi-perimeter is first, which is going to be each of the sides, 125 plus 70 plus 65, all divided by 2, because it's half the perimeter. So the semi-perimeter in this case is going to be 130. So when I go to plug that in, this is going to look like 130 times, and then remember, if you do want to use parentheses, it's not going to be the end of the world. It's really not that big a deal, but I'm just going to go ahead and subtract it in my head. You might want to subtract it off on the side and like make a list of what is s minus a, what is s minus b, and what is s minus c. So this is going to be 130 times 5, because 130 minus 125 is 5, and then 130 minus 70 is going to be 60. And then 130 minus 65 is going to be 65. So I'm going to type that whole thing into my calculator. And again, normally I would just type this in as the square root of 130 times 5 times 60 times 65 without using all that many parentheses. And that's what I would do to get started. And then I'm going to find that the area is approximately 1592 feet squared. I'm not going to round it. When I do the very end of the problem, I'm going to now multiply this by 1.15, and I'm talking about the answer that I have in my calculator by $1.15. So I'm not rounding it before I just hit times answer, or times 1.15. Okay, so then your final answer should be that the cost is $1,830.99. Okay, that's what I would get for the final cost, and that's the end of section 9.4, which is probably the fastest section of all.